Welcome to the video on solutions to systems of equations. And we're given a question where we have to find the number of solutions to each of these three systems of equations. So let's just remind ourselves, what does it mean for a system of equations or a system of linear equations to have solutions? So essentially, it just means that the points of intersection of two lines. So I have these two lines. This point where they both intersect is the solution of the system. So you might be thinking that, well, they should just have one solution because there are two lines and they should have only one solution. But this is actually only the first case where you have one solution. You could also have two lines that are parallel to each other. So parallel lines means that both of them have the same slope, right? And so they are parallel, and so they will keep on going in the same direction forever and never meet. So they will never have a solution, so that would be no solution. Okay, and the final type would be where both the equations would essentially be the same. They would just be multiples of one another. This would mean that one equation, for instance, one equation could be x plus y equals to 2. So another equation that would have infinite solutions, if I to make it a system. So if my second equation is 2x plus 2y equals to 4, notice I just multiplied a 2 to both sides of this equation. And now if I try to solve this system of equations, this system would have an infinite number of solutions because they would essentially be the same line. They would be the same equation. So at any point on the system, both lines would have the same points for x and y. So let's just use this information to try and find the number of solutions for each of these systems. So for the first one, the first thing I need to do is I need to check if they have the same slope or not, because if they have the same slope, then that would mean that there are no solutions. So let me see. The first equation, let me write that in the standard form, which is y equals mx plus c, where m and c are some constants. In that case, our slope would be m. So for the first equation, it would be, in this system, it would be 2y equals 4x plus 6. So I'm just going to divide both sides by 2. So that would give me y equals to 2x plus 3. Now notice the m here in both these equations is the same. It's a 2. So the m here is also a 2, and here as well. And notice that this constant term is different in both of them. So if the constant term would also have been the same, then these would have had an infinite number of solutions. I forgot it right here. But since the constant terms are different, so this system has no solutions. Okay, for the second one. Now first let me check once again for the slope of both of them. So for the first one, I'm going to write this as y equals to a negative x plus 3. I just subtracted an x from both sides to bring it into this form, and so our m here is a negative 1. For the second one, I'm going to do the same. So I have a 5y equals to a negative 5x plus 15. So once again, I'm going to divide both sides by a 5. So I'm going to get y equals to a negative x plus 3. Notice, not only is the m the same in both of these equations, but they are essentially the same equations. Once I put them in a standard form and simplify them, they are the same equations. And so this system will have an infinite number of solutions, because not only was the m the same, but the constant, the plus c, was also the same once I put it in the standard form. And now let me do the last one in a different color. I should have done a different one for this too. Okay, so for this one, let's first check for the gradient or the slope of both of these lines. So for the first one, it's going to be y equals to a negative 2x plus a 3. I just divided both sides by a 3. to put it into this form, the standard form. And so my m here, in this case, the slope is equals to a -2. And for the second equation, it's already in this form, so my m in the second one is a -6. So these cannot be this. So obviously this system does have a solution because the m's are not the same, so it cannot have no solutions, and the constant is also not the same, and even just by knowing that the slopes are different, we know that it cannot have infinite solutions. So this system will have only one solution.